I'm going to do a couple of samples of dilations here. One of them is centered at the origin. One is centered at a point, not the origin. So the first one where it's centered at the origin is kind of a dilation that you have most likely seen before. And this scale factor here is a half, meaning that the new one is going to be, half. Each point will be half of the distance away from the origin as the original one. And so I'm going to start this by, I'm going to plot the original one, then I'm going to find the new one and show you how we can see, that it's centered at the origin there. So A is at -6,2. So there's original for A. B is at -4,4. So there's A, here's B. And C is at -2,2. So here is our original figure. I'm going to connect it in orange so we can see the old versus new. So there's the old figure. And the new one is going to be to take each point and you want to go half of the distance from the origin of what it already is. So like currently C is back 2 and up 2. So instead of going back 2 up 2, we're going to go half of that and go back 1 up 1. So there's C prime. Now, with it centered to the origin, what is so great is that it's really just dividing everything by 2. It's half of everything. So if you just take half of your points, you'll be in the right place. Now, if it's not centered at the origin, you cannot do that. So I was trying to describe how you would do it, without just doing half of each point. So here's the new C. The new B is at -2,2. So the new B is the same as old C. That's B prime. And then A is going to now be at -3,1. So there's A prime. And then we'll connect them. Get a nice green. It's a pretty small triangle. Now, if you want to see how we can tell where it's centered at, you can connect the origin, the old and the new on the same line. And you can kind of see how they will go through to the origin there, and it kind of looks 3D, sort of like a projection. That's not needed, but I wanted to show you how you could visualize that. So anyways, that's the answer. They wanted us to graph the polygon in the image. They did not tell me to list the new points or anything, so that's all I had to do there. So now on the one on the right, it's a little bit tougher because it's not centered at the origin right now. It's centered at point A. So we're going to plot the original and then we're going to plot the new. So for the original, A is at -3, -2. B is at -2,1. So there's A, here's B. C is at 0,3. Boy, this is going to look weird. D is at 3,4. Okay, so I think it's just a really strange, squished sort of trapezoid picture. So I'm going to connect. There we go. So in this case, we are going to dilate with the center at A, meaning that A will stay exactly where it's at. And the distance from A to each point is going to be multiplied by the scale factor here, which is a 2. So we are doubling the distance from A to each point. So basically I'm just going to do like counting of a slope and then I'm going to double that slope to get the new one, which point D might be off the grid here. I made this problem up today and I didn't realize how large it was going to go. So we'll just see how it does. So for new A is not going to go anywhere because it's centered at A, so the distance from A is 0, and 0 times 2 is 0. So A and A prime are the same spot. For B, it's going up 1, 2, 3, and over 1. So we need to double that. We need to do that again. 1, 2, 3, and over 1. So now it takes 2 of the same stair step to get there instead of 1. So there's B prime. So it's not really very hard to do. It's just that you haven't done this before. From A prime to C is going up 1, 2, 3, 4, 5, and over 1, 2, 3. So go again, 1, 2, 3, 4, 5, 1, 2, 3. There's C prime. And then for D, it's going up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6. So go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, perfect. Fit perfectly. And then we're going to connect the dots, and you're going to see how it has changed with respect to A. So there's A to B prime, and then to C prime, and then to D prime, and then back to A. So you can see it's sort of like you can connect C and C prime there and see how it's projected out there. You can see that the side AD is now 2 times its length. The side AB is now, like A to B, A prime, B prime is twice the length of AB. From B prime to C prime, you should be able to count and kind of use the slope to tell that it's double the length of BC. And C to D, C prime to D prime will be double the length that it is from C to D. So here is a dilation that's not centered at the origin. It was centered at A.